Okay, just to start off again, we're going to do the intro to chapter 7.1 and 7.2. Simple interest is a special word for arithmetic sequence. That's it. Okay, we're going to be adding a certain amount every single time, and we're going to see what our final amount is after we count out the number of, I guess, terms. Okay, compound interest is another fancy way in finance to say geometric sequence. So before you forget, I like you to write that down. Simple interest is another way of writing arithmetic sequence. And underneath in compound interest, I like you to write down geometric sequence. Okay. So let me change this up a little bit. That's arithmetic. I don't need these highlighters. And this is geometric sequence. Now, every time I do the calculation on the bottom, you will see a equation, but more than just the equation, I like you to see how similar it is to the equations we've had for arithmetic and geometric sequence. Also, the question suggests that we are going to invest. We're going to start by looking at how money can grow using interest. And it says that we're going to use $1,000 as an investment, and then I accidentally wrote 100 here. So if you want to change that up and say it's a $1,000 investment, okay, on the bottom two, it's going to be $1,000, okay? That's my fault. In case you're wondering where that's from, take a look at the very top paragraph. The very last sentence, I'm going to be using two different scenarios. So let us, last line, compare these interests using a $1,000 investment that will earn 5% interest per annum, which is a fancy way of saying per year. Okay. Calculate the amount $1,000 will grow to after 1 year, 2 year, 3 year, and 10 years. This is simple interest. And remember, it's arithmetic sequence. In the first year, so right now, I'm going to say year zero, okay? So it doesn't really, sorry, year zero. It doesn't really count. Right now, I have $1,000. Well, how much interest do I earn after 1 year? Well, it's at 5%, right? So what is 5%? So interest, I'm going to do capital I. Interest is equal to 5% of 1,000, which is the same as 0.05 of 1,000. And if you do that in the calculator, it will turn into $50. So you put $1,000 somewhere, you get back $50. That might not seem like a lot, but baby steps go a long way. $50, you could think about it as 2 or even 3 hours of your work, right? You're basically, if you think about it, you're trading 3 hours of your life for $50. I don't know if that's worth it for you, but when you're younger, you got to do what you got to do, right? People don't know your worth. They don't know how amazing you are. So you got to start small and prove to the world that you're worth more than $15 an hour. That's basically how it starts. Let's continue. So if this is going to be my interest per year, T1 would be what? 1,050. Year 2 would be another 50. So it would be 1,100. Term number 3. So in 3 years, it will be 1,150. 1,150, sorry. Okay. This is simple interest. In other words, the interest does not change. It is always based on original, and here's a math word, or here's a finance word, the original principal. What is the principal? Take a look at the box above. In math linguas in the world of finance, principal means the original lump sum that you're putting in. So simple interest is always going to be calculated on the principal, not how much you have right now, always the original amount. That might be good sometimes, that might be bad other times. When might that be bad? Give me an example of when that might be a bad way to earn interest. Something simple. Yes, Ian? Sure, right? If you put in $2,000, you'd want, if you have $2,000 in the bank, you'd want 5% of that, right? But it still calculates 5% on the original 1,000. So you feel like you're getting gypped. When would that be a great way to calculate interest? Yes. Sure. Like credit cards, and it's growing and your bill is getting bigger and bigger and bigger, right? Unfortunately, the world doesn't work that way. This is actually how credit cards work, but it's to your detriment. Let me explain. Here's an example. You don't have to copy this down. And this is a lesson for you because this is literally how the work. Let's pretend you borrow $1,000 from the bank, right? From you spend $1,000 on your credit card, and you got to pay back. You pay back $100 next week. You pay back $500 the week after, and you pay back another $399, which means you have only $1 left on your bill, and then you forget to pay it. The credit card company will charge you interest on the original 1,000 you borrowed, not the $1 left. Credit cards will use simple interest because that way they can maximize the amount of money they take from you. That's why that's why a lot of parents will say, don't use your credit card unless you have the means to pay it off the next day. Right? A lot of people play dangerous games with credit cards thinking it's free money, but it's not. It's really, really dangerous. So be careful. Okay. So since we want to keep it simple, let's focus our attention on how to make money with interest. We want to think of a better way to earn money instead of simple interest. And you might have guessed it. If you did enough practice with geometric sequences, you know that the value increases incredibly fast if you're using geometric sequences. So let's take a look. Oh, before I move on, sorry. If you want to calculate T10, so we have T1, T2, T3, let's figure out how to calculate T10. It's it's an arithmetic sequence. So you can say, here is my starting value, 1050, I guess. And we can add that with n minus 1 times 50. Right? That is 1050 plus 9 times 50, 450. The total amount after 10 years is going to be $1,500. If you don't want to memorize a new formula, you can just assume that Tn is equal to A plus n minus 1 times D. However, because we're dealing with money here, I want to change some of these words into the appropriate letters. Tn, in terms of money, will be the final amount. Yes? Final amount that I have in my bank account. So we replace it with the letter capital A for amount. A is my starting value. And the starting value in the world of finance, we call it principal. And lastly, n minus 1 times d is how much interest we gained on top of it. So we can calculate the interest we gained by using a tiny formula called principal multiplied by the rate, so 5%, multiplied by how much time you're going to leave there to earn the 5%. Shall I show you? Let's erase this for a bit. Okay. Let's pretend we're using this formula. A is what I want to find after 10 years. T is 10 years. My R is 5%. And my principal is, I'm putting in $1,000. My final amount is P plus PRT, which is $1,000 plus 1,000 times R times T. That becomes 1,000 plus, put that in the calculator, you will get 500. The final amount is, again, 1,500. Same thing. So if ever in the future you have a question that deals with simple interest, it's just a simple formula. A is equal to A plus P, A equals P plus PRT. And PRT, put a little highlighter here. PRT represents the interest. PRT equals interest. Right there. Right? So PRT, interest. So if I ask you, hey, how much is in your bank account? Well, it's 1,500. How much interest did you earn? You can either calculate PRT, or of course you can do a subtraction with $1,000, but I'm just trying to prove a point. Simple interest. We're half done our lesson. Any questions? No? So far, so good? All right. Let's take a look at how we can earn more money. I'm going to clear this. Compound interest. So same thing. This is going to be $1,000. Excuse me for that. But this time around, we are able to earn interest on our current amount of money. So right now I have $1,000, right? Yeah. So after, you know what? Let's do it this way. Let's pretend right now. So T1 is going to be $1,000. But T2, in other words, 1 year after, I get to take that 1,000 and I'm going to multiply it with 1.05. And remember, this means my original 100% plus the additional 5%. Right? So I'm multiplying it, so I'm growing it by an extra 5%. Please remember that it's very much like our exponential functions unit. Try to remember. So this is chapter 3 if you want to go back. Term 3, in other words, 2 years after, I get to multiply this by 1.05, right? Because that's term number 2. And whatever I have here, whatever my actual amount is again multiplied by 1.05. In other words, this is multiplied by 1.05 twice. But sometimes it's hard to see what this is. So instead of just writing it like this, I'm going to actually calculate. What is 1,000 multiplied by 1.05? It is 1,050, just like before. But instead of adding an extra 50, I'm adding or I'm multiplying another 1.05 to it. Calculator handy? Ian, can you do that for me? 1050 times 1.05. Yep. Okay. Compare that with year 2 above. How much was I supposed to have in 2 years? In the first example, simple interest. 1,100. How much more money did I make? 250. Is that a lot? No. Where did that 250 come from? You know that extra 50? Yeah. You know that extra 50 bucks? That extra 50 bucks made a tiny 5% for you. So you made 5% on the 1,000. You made 5% on the 5%. You see where this is going? It's going to snowball. So take a look. T4. I have my original value of 1102.50, and that's going to be multiplied by another 5%, which is 63. 625. Okay, yeah. So in terms of cents, it makes sense. I'm going to round to 2 decimal places. That compared to, I'm going to do the math quickly, 1150, you have an extra $7.63. Where did that come from? Well, you made 5% on the 50, right? You made 5% on the 50, and then you made 5% on the 50. You made 5% on the 5% on the 50. Wow, that's complicated. But you're basically snowballing. So if this was the case, if this went to, so T1 is my 0 year. So if this went to term 11, in other words, year 10, that would be my original amount multiplying with 1.05 for 10 years. Where's that equal to? 1,000 something. Yep. Point. Sounds good. Versus simple interest of 1,500. So for 10 years, I know it's a small amount, but we're only dealing with $1,000 over 10 years. That's like saving $100 a year, which is nothing. Especially if you have even a part-time job, you can do that, right? And that alone will get you an extra $128.89 for doing nothing special, but just calculating interest in a different way. Any questions so far? No? Before we go on, please consider the formula, the total amount. So A, in terms of financial wording, the principal again is the same, the starting amount, but instead of multiplying or adding a certain D value, I am multiplying by 1 plus R, where R is the rate. And I think you might see this as a familiar equation, familiar formula from the exponential chapter, okay? And T, of course, is time. But there's a catch. There's a catch. Just as you can use this method to earn money, the banks can also use this method to earn money. But of course, this isn't as simple as the real life. There's more that we can do to snowball faster. You know, in this example, we learned how the interest can make interest. So you can make your money work for you. Your money is working for you to get bigger. You didn't do anything to earn that extra 50, but the extra 50 that you earned is now earning money for you. And the money that you earned from the 50 you earned is also making money for you. And now the money that you made from the money that you made from the 50 that you made is now making money for you. I'm going to keep on repeating myself unless everyone nods and that say that they gets it. No, I don't have to repeat myself. Okay. But there's a catch. If money can make money for you, it is in your best interest to get that money made as fast as possible so that your money can make money for you as fast as possible. Does that hit home for anyone? Do you understand what I'm trying to say? So the faster you earn interest, the faster your money can work for you. So you're trying to make interest as fast as possible. Consider how we can do that without doing any work at all. Flip the page. There's a catch. There's a catch to what I gave you for a geometric sequence. Ready? Let's read the question together. A bank service offers an interest rate of 12% per annum, so per year. Amazing. However, you are too impatient to wait. Is it fair to ask the bank to give you 1% every month instead of 12% after 1 year? On paper, is it fair? Right? 1% January, 1% February, 1% March. You add that up for 12 months, that's 12%. On paper, it seems fair. But what does it look like when you actually do the math? Let's compare. I'm going to do something called 12% per annum calculated every year versus 12% per year, but calculated every month. So this 12% is going to be calculated once. This 12% is going to be cut into months and calculated 12 times. Consider this. Okay. So let's hash this out. If this is going to be a question that you're going to do for me, I would like you to write all the information on the left-hand side so that you know what information you're dealing with, what numbers you're working with. Your final amount is what you're trying to find. The principal is 1,000, just like before. The rate is 12%. In other words, it's 0.12. I'm adding a new letter, N. N stands for number of compounding or compound periods. In this case, how many times am I compounding in a year? It says compounding annually. I'm calculating how many times a year? It's annually, so just once. All right. And so what is my actual interest rate? It would be 12% divided by once a year. It's equal to 0.12. That's my interest rate. My final amount is going to be 1,000. So that's my principal. 1 plus 0.12. And I do that once. What does that turn into? Some people with quick mental math might be able to calculate that. It's 1,000 times 1.12. So 1120. So the bank from January, if you put this in January, at the end of December, they'll give you $120. Amazing. Now let's take a look at if I were to calculate it 12 times in a year. 12 times in a year, compounded monthly. So N equals 12. My final amount is my question mark. My principal is still 1,000. My rate is still 12%. But because my compounding is 12, that 12% has to be divided into 12 pieces. So each time I'm calculating it, I'm actually calculating 1%. Does that make sense? Is that fair? 12% over the year, so 1%, 1%, 1%, 1%, 1%, 12% in total. But if I'm to put this into the calculations, my 1,000 principal, 1 plus, I'm putting this in here, okay? This is 0.12 divided by 12. That's going to be 0.01, right? And then I'm only doing this for 1 year, but how many times am I doing this in a year again? 12. So I'm going to multiply that by 12. Right? So I'm doing this 12 times, and the amount that I'm doing this is actually just 0.01. It's a lot smaller than 0.12. Everyone ready? Everyone understand what numbers are being used right now? So this is the same as saying 1% 12 times. Someone work that out on the calculator for me. Yep. Anyone else? So it's confirmed? I realize I made a mistake in my answer key here, so I gotta write a new one. Confirmed? I see Nathan with the calculator. I'll wait for it. Okay, everyone's getting a slightly difference. 1.01 to the power of 12. 825, so sure. If we round it, 8.3. But it sounds good. Okay, so you have to multiply by 1,000. Remember that. Okay, so are you doing anything new? Are you doing anything special in terms of saving money? No. And both of these examples, left and right, are both compounding. In other words, they're geometric sequences or geometric sequences. But remember the point we made. The faster you earn your tiny bit of interest, the faster your interest can work for you. And so instead of waiting a full 12 months, you will make your first interest in the first month. And it starts to snowball little bit by little bit. So after the first year, you earn $6. Can we do something interesting? Let's see how far that $6 will take us. Can you compare? I'm going to erase this just in your head. Can you do the same thing? Let's pretend I did it for 10 years. And for this one, I also did this for 10 years. In other words, I'm doing 0.01 for 120 months. How much do you get if you compound annually for 10 years? Someone do that for me. And then, Jonah, can you do, if you could compound it monthly for 10 years with the 120? Uh-huh. Yeah, no, can you do the bracket first? 1 plus 0.12 to the power, yeah. And then, no, equals, in case you don't have brackets, 1.12, that is to the power of 10, equals, multiplied by 1,000. Okay, that's decent money. If I were to compound it monthly for 10 years, 329, so 33. Pardon? 38639. Okay, again, that $6, because you snowballed it earlier, it gets to work for you that much faster for 10 years, and it has grown to $200. And we don't have to think about $1,000. We can think about a much larger value, because I think maybe you might be able to save more than $1,000 over a year's time, right? It's stuff to think about. It's stuff to think about. So this compounding business, when you compound it annually versus monthly, it can make incredible differences. Let's hammer out the equation. So from now on, The one thing that's different from exponential functions is that your rate can be divided by the compounding number, and your exponent is going to be multiplied by that same compounding number. Okay, so the number of compounding periods, please note, I'm going to write something on here that I like you to copy down somewhere in your sheet. If the question says yearly or annually, that means my n value is 1 because you do it once a year. What if I said it was biannually? This is a bank term. What is the n value if it's biannually? Trick question. If I said semi-annually, how many times am I doing in a year? 2. Because every half a year I calculate. You get it? And like semicircle, half a circle. Semi-annually, I'm calculating it twice in 1 year, so n equals 2. Let's keep going. Leave a space. What if I said monthly? How many times am I calculating in 1 year? 12 times. So what if I said it was quarterly? How many times am I calculating in a year? 4 times, every 3 months. What if I said it was bi-monthly? 6 times, every 2 months, right? What if I said it was semi-monthly? So this is all bank terms, semi-monthly. 24 times, good. And here's another trick. Instead of semi-monthly, sometimes banks will start charging you bi-weekly versus weekly. How many weeks are there in a year? 52. That means if I charge bi-weekly, 26. Very subtle difference, but it can make a huge difference on your invoice, on your documents. And lastly, I don't think you'll ever see this in the actual real world unless you have a line of credit. But anyways, daily is equal to 3, 6, and 5. There's no such thing as bi-daily. I don't think anyone does that. So depending on what the question says, please be careful of how often you compound. The value of n will change. Okay. As an example, let's do, so these questions I already have online. Let's see. Okay, let's do number 2. Miss Who, ooh, sorry, in case you need this. Can you see this? Let me make sure I make it smaller. Okay, I hope you can see that. Okay, Miss Who needs $10,000 to go on her dream vacation in 3 years. How much does she need to invest? Oh, no. Okay, maybe number 2 is a bit harder. We'll do number 1 to use the formula, and we'll use number 2 to see how the formula can be adjusted. Okay, Mr. What invests $1,500 in an account, earning 3.3% annual interest, compounded monthly. What will her investment be worth in 5 years? So 1,500, 3.3 monthly, 5 years. Let's go to the whiteboard. I'm gonna write this down. Let's see. The principal that I'm dealing with is 1,500. The rate that the bank gives me is 3.3%, so it's going to be 0.033. The compounding period is going to be monthly, so it's going to be 12. And the amount of time that I'm waiting is 5 years. Let's do it. What is the final amount after 5 years? It is P 1 plus R divided by N n times t. Principal is 1500. R is 0.033. The n value I'm dividing by 12, and this is 12 times 5 because of 5 years. For people who might be a little tripped up on the calculator, please follow suit. What you're going to first do is do the bracket. So do 1 plus 0.033 divided by 12. If you do it in that order, the calculator will do the division first because it follows BEDMAS. And it gives you the answer 1.00275. I will wait for you. See if you get that on your calculator. This answer is then going to be put to the power of 60. And whatever your answer is, take that answer and then multiply it with 1500. This should become 1,768 and 69 cents. So I'm going to do the same thing with number 2, but consider what information they give you and what you have to find. Number 3 and 4 are exactly the same. I give you a mix of different values, and you're going to have to figure out what the unknown value is. What is it that they're actually asking for? Number 2, I'm going to clear. I'm going to write this. Let's go back to the sheet so you can read it. Miss Who needs $10,000. That's not the principal. I need $10,000 to go on her dream vacation in 3 years. How much does she need to invest now in an account earning 4.5% annual interest compounded semi-annually? The whiteboard. If you didn't recognize it already, question 2 gives me the total amount that I need at the end. And the amount of time right away after 3 years. I need this money after 3 years. How much do I need to invest now? So principal, if the bank account is going to give me 4.55%, which is 0.045, and I am calculating or I am compounding semi-annually every half year, so twice a year. If you plug into the formula, we have 3 years times 2. I just want to draw your attention to how the n value appears twice. Right? Whatever the year is, I am multiplying and dividing. So sort of, it's supposed to even out, but of course it's not the case. So let's solve it. I don't know what P is, but I'm pretty sure I can solve this portion. Calculators, please. What is that part equal to? Let's see if you can do that without me having to hold your hand through it. Yes, and then can you do that answer to the power of 6? 2, 5, whatever, right? So try to keep as many as possible because we are dealing with money here. So I'm going to actually not clear my calculator. This is why I've always recommended calculators that have the answer button. You can use that to your advantage. What you're going to do is do 10,000 divided by the answer key, right? So what you're going to do by doing that is if you do 10,000 divided by 1.1428254415647, right? That's the answer button. If you do that, my principal is equal to 8,750.24. So you put $8,750 into the bank account. In 3 years, it will grow to 10,000, and you can pull that out, and then voila, you have your vacation. There's question 3 and question 4. You can follow the same, I guess, procedure by taking a look at what information is given, and then you can plug it into the equation, which will identify how am I going to find the unknown? What is it that the question wants me to calculate? And that's the end of chapter 7.1 and 7.2. Simple interest, it exists in this world, so you still need to learn it, but it's not as popular. Compound interest, it takes so many different shapes and forms in this world. At this point in time, those of you who are more like entrepreneurs and those of you who are more interested in being financially free, those of you who come from backgrounds where there were hardships when you were younger, like there were 2 hardships when I was younger. When I first came to Canada, there was a huge recession. And in the second wave, there was another somewhat recession in 2008. There was a huge stock market crash. Okay. I was a young professional at that time, I guess. That's the best way to do it. It's very similar to when I sort of started teaching in a sense. And on top of that, being a family of 5 with 3 children in the family, my parents really, really had to work really hard. And so the concept of money was always in the back of my mind, right? How can we be richer? How can we be more successful? Not that money is the end of the world, is the end all and the solution to all our problems, but it's important. It's absolutely important, right? And those people who say money can't buy happiness, they've never been dirt poor. They have never been poor before, right? I do believe money is not the solution to everything, but it's important. And so to be financially free is an incredible achievement, more than any university certificate, more than any Nobel Prize. To be actually free from banks and institutions, right, is an incredibly, amazingly like celebratory thing to be. So those of you who are more inclined in that way, your brain is probably starting to gear and rotate right now, right? When I get to 7.4 and 7.5, I'm going to give you a small tip on why and how you can technically be head and shoulders richer than I will ever be in my lifetime. And that's simply because you're younger than me. That's ultimately it. Okay, so let me show you that math once you get there. Right now, we have a lot of time. I'd like you to try numbers 3 and 4, check your answers with what I put up online, as well as attempt the questions from the textbook. Specifically, I'd like you to take a look at number 13 in the textbook. The rule of 72 is a very interesting concept in the financial world. The more you know about it, the more educated you are on it, I think the better you will be when you in the future. Yeah, absolutely. Noah, question? A personal one? Yeah, sure. I'll be right there. I'm going to pause the video now. Please do the homework. And if you need me, call me over.